Hello everyone, welcome to Helm of Science. So in the last video, we had talked about the probable questions that can come from electrochemistry chapter in your joint entrance examination. So today we shall be doing another set of questions from the chapter Chemical Kinetics, which has equal importance and shows different concepts from the chapter which are important for your competitive examination point of view. Now, before I start off with the video, I know that your joint entrance examination has been postponed and it's in a kind of dilemma situation whether it will happen or not, or if it at all happens, then when it will happen. So, even if there is so much of dilemma and so much of uncertainty, we have to continue doing our preparation instead of getting demotivated. I know all of you have become very demotivated, very frustrated due to the postponement of all the examinations, both your board as well as joint. But I hope this series will help you to keep your motivation level boosted up so that you have the energy, the confidence, and the determination to clear your boards as well as your joint examination whenever it happens. The only motive for doing these test series from my side is, or these revision series from my side, is to keep you updated with different kind of questions so that your preparation pathway does not become monotonous in these dire circumstances. So I hope it will be beneficial for you. Without any further wasting of time, let us start off with the video. Alright, so the first question that we shall do from Chemical Kinetics is the rate law for the reaction 2N2O5 giving 4NO2 plus O2 can be given by one of the following expressions, and there are three expressions given to you. Right, so let us start with the solution for this particular question. So the thing that has been given to you, that is the reaction, is 2N2O5 giving you 4NO2 plus O2. Right. So now there has been three rate expressions given to you. What are the expressions? Expression number one is minus D of, or change of concentration of N2O5 with time, equal to rate constant K1 into initial concentration of N2O5. Right. Rate expression number two that has been given is minus change of, plus change of concentration of NO2 with respect to time is K2 into initial concentration of N2O5. The third one that is given is change of concentration of O2 with respect to time equal to K3 into N2O5. Right, now before we begin the solution of the question, what is important is to understand a few things. That is a recapitulation from my end. That is, you'll see that on the right hand side, we have done every rate equation on the basis of reactant concentration, right? So that is fixed. Another thing, if you notice, for N2O5, we have used the sign minus, and for NO2 and O2, we have used the signs plus. Now, why is it so? The thing is, students, that N2O5 is a reactant, right? So with time, the reactant will decrease. That is why a minus charge has been, minus sign has been given. Whereas NO2 and O2 are products. So products should increase with time. That is why we have given a positive sign. Alright, so that is the base, the main, what do you call, the implication or the message from the question. Now, what do we have to do is, there are certain relations given in the question. We have to prove that which relation is correct. Now, children, see one thing. Whenever we are writing a rate law, it was actually told to you initially, wherever you have studied, that rate law should include the coefficients also which the individual components are multiplied with. So in case of N2O5, this should be minus 1 by 2. The coefficients are written on a reciprocal basis of d of N2O5 by dt. This should be the actual rate law. Right, now if we are multiplying the rate law with or the change in concentration of the reactant with the coefficient on the left hand side, so we have to do it on the right hand side as well. Why? So as to maintain the format that was given to us in the question. Right, for NO2 what we'll do, it should be 1 by 4 of d of NO2 by dt equal to 1 by 4 of K1 into N2O5. This is 1. And for O2 there is no change because there has been no coefficient mentioned to us. Right. So this should be this should be K2 and this is K3 into N2O5. Alright. Now we have got a form which we actually rather I should say we have got a desired form. Right. Now what do we actually do? We write the rate of change of reactant concentration D of N2O5. Reactant concentration should be equal to the rate of change of product concentration. This is the basic principle of chemical kinetics, right? So if this is valid, then the right hand side should also be valid. How? So this should be 1 by 2 of K1 N2O5 should be equal to 1 by 4 of K2 N2O5, and that should be equal to K3 into N2O5. Now cancelling out the common factor, that is N2O5, which is not a required part. So how can we do this? If you multiply all the three parts with 4, what will happen? 2 cancel out 4 by 2, K1. This should be equal to K2. And if it is multiplied by 4, then this should be 4K3. Right? So this option is option number D. Right, students? Oh, sorry, this is option number B. I'm sorry, option number B. Now, one thing you should see, students, the option number B is given in a very tricky format. Have you seen? On all the three formats, K1 equal to K2 equal to K3 is given with whatever coefficient, that is not the point, but the relation is given as K1 equal to K2 equal to K3. But in case of option number B, they have just mixed the order. So whenever you're doing a problem in competitive exams, be alert, students. Try to analyze the questions properly. Alright? Try to see what is given and what is not given for your own benefit. If you try to skip the questions, then what will or the options, what will happen is you will miss out the answer that you have got. Right? So let us move on to the next question. Now the next question states that the unit of the rate constant for a reaction with an overall order of 3 by 2. Okay. Now, rate constant K of any reaction can be given as concentration to the power of 1 minus n into second inverse. Alright. Now, this is one formula you should always keep in your mind for your competitive exam's sake. This is very, very important, students. Alright. Just so that you can get to the answer very quickly. Alright. Now, n or the order of the reaction mentioned to is 3 by 2. So, we can write concentration to the power of 1 minus 3 by 2 second inverse. Right. 1 minus 3 by 2 is minus half. So, concentration to the power of minus half second inverse. Right, students? Now, what is concentration? See, the concentration unit that is given to you is mole per liter, or molarity is given to you. So, use that. So, mole liter inverse to the power of minus half, second minus 1. Now that what is going to be the answer? Mole minus half, mole to the power of, we'll write minus half, liter to the power of plus half, and second inverse. Check your options. So that is option number C. Understood. So for any reaction where there is order given or you have to find out the order, try to use this equation. So mark this equation very carefully in your notebooks. Okay. So moving on to the next question. Question number 3 states, now this is a very tricky question. It states that for an exothermic reaction A to B, the values of activation energy and the heat of the reaction are 40 kilojoule per mole and 15 kilojoule per mole, the activation energy for the reverse reaction. Alright, so the question that is given to you is A to B is an exothermic reaction, and mark that word very carefully. So, if it is an exothermic reaction, means when the reaction happens, heat is released. Right. Now, if heat is released, see, in the question it was mentioned to you the activation energy EA for the forward reaction, let's mark it by F, is 40 kilojoule mole inverse. And the heat of the reaction, that is delta H of the reaction, is mentioned to as 15 kilojoule per mole. Now, if the reaction is exothermic in nature, that is heat is released, so the total heat of the reaction would be negative because energy is being released. Yes or no, students? Right. So, we can say that the entire change of or the entire heat of the reaction would be equal to the forward reaction activation energy minus the backward reaction activation energy. Right. Or EA backward. Now, this is minus 15. This is forward reaction is 40 minus activation energy of backward. So activation energy of backward reaction will come out to be 55 kilojoule per mole. Now check that whether this is there in your option. Yes, it is. Option number D. So is it clear how to do? So these terms, exothermic, endothermic, they are very important conceptually. Alright. So let us move on to the fourth question. Now, question number 4 says, for two reactions, the values of K1 and K2 are 10 to the power 16 e to the power of minus 2000 by T and 10 to the power 15 e to the power minus 1000 by T, respectively. The temperature at which K1 equal to K2. Now, first things first, students, whenever you're seeing this question, you should be able to identify the form of the question. That is very important. Because if you do not identify the form of the question, then it doesn't make sense. You will not be able to attempt the question at all. Alright. So, what is the form of the question? See very carefully. It is mentioned K1 equal to 10 to the power 16 e to the power of minus 2000 by 2. Right? Now, if you carefully observe, this resembles which equation? The Arrhenius equation format. How? K is equal to A e to the power of minus EA by RT. Right? This is the Arrhenius equation format. So, identifying the format of the question is very, very important to proceed with the question forward. Otherwise, it's very difficult. Alright. Now, K2 is given as 10 to the power 15 e to the power of minus 1000 by T. Okay. Now, we are comparing both the equations with Arrhenius equation. Now, in the question it is mentioned K1 is equal to K2. So, for that matter, what can we do? We can do is, just let us write 10 to the power 16 e to the power minus 2000 by T should be equal to 10 to the power of 15 e to the power of minus 1000 by T, since K1 equal to K2. Right? Okay. Now what can we do? Divide 10 to the power 16 by this factor. This comes this side. So that will be 10, right? 10 e to the power of 2000 by T. 2000 equal to e to the power of minus 1000 by t. Now, you're stuck in this place, suppose. Alright. What would you do? See, one more thing that can be done is very carefully observe that we can write. Okay, let me just scroll the page a little down, otherwise I don't think you can see. Just a second, students. So, what we can do here is, keeping the 10 this side, we can divide this factor, the e factor, onto this side. So, just for your information, e to the power of a by e to the power of b would be equal to what? E to the power of a minus b, right? So, doing the same thing here, this should be minus 1000 by t, minus of minus, that is plus of 2000 by t, right? So, this becomes 10 equal to e to the power of 1000 by t, right? Okay. Now, what can we do? We can use the factor, the ln factor here, right? So, what we will do is, we will apply ln on both sides, okay? So, what do we do? ln of 10 is how much, students? Just check on your calculator. It is roughly at around 2.303. So, applying ln on both sides, ln 10 equal to ln e, and also to the power of e will get cancelled. So, that will be this, and this is 2.303. Alright, and this is 1000 by t. So, your t becomes what? T is equal to 1000 by 2.303. Right, students? So, this is your answer. Now, this matches which option? This matches option number B, right? Okay. Clear so far? Alright. So, one more thing, in the option, you might ask me that, ma'am, what is the K? The K is basically Kelvin, unit of temperature, alright? It is nothing new or term, or not the rate constant. So, don't confuse it. Alright. So, let us move on to the next question. Question number 5 says, for a first order reaction, the time required for its 10% completion at 298 Kelvin is the same as that for its 40% completion at 320 Kelvin. The activation energy for the reaction is. Alright. So, we'll do it in two cases. Case 1 and case 2. For simplicity's sake. Alright. What is asked? Case 1 says that for a first order reaction, the time required for 10% completion. Okay, fine. Alright. So, first order reaction is 2.303 by t log of A0 by A0 minus x, right? Now, this is going to be a very lengthy question, but the question is very, very important in terms of your competitive exam point of view. Alright. So, let us just put it as T1 maybe and K1, right? Okay. So, initial concentration, if it is A0, then 10% completion is happening. So, A0 minus x is going to be A0 minus 10% of A0. So, remaining concentration would be 90 by 100 of A0. Right, students? Yes or no? Okay. Now, what we can do is, we can write, substituting the formula, K1 equal to 2.303 by T1 log of A0 is already there, and A0 minus x is 90 by 100. So, we can write it as 10 by 9. A0 gets cancelled out. Okay. Now, case 2 says K2 equal to 2.303 by T2 log of. Now, how much is it completing? 40%. So, 40% completion means A0 minus x is A0 minus 40 by 100 of A0. Right? So we can write it as this would be equal to 60 by 100 of A0. So that would be 10 by 6, log of 10 by 6. Right? Now it is saying the time required is the same. Alright. So if time required is the same, then uh, what can we write? We can write is, what can we write? We can write, okay, I'm doing it here. T1 should be equal to K 2.303 by K1 log of 10 by 9, right? And T2 should be equal to 2.303 by K2 log of 10 by 6. Right? Now equating the two, because it is said in the question very clearly that the time taken is equal. Right? So what will we do? We will write it as, what was the first one? 2.303 by K1 log of 10 by 9 equal to 2.303 by K2 log of 10 by 6. Right? 2.303 gets cancelled. Okay. So we can write K2 by K1 equal to, now what you can do is you can solve it individually, the log values, or you can just bring it on this side, that is on the right hand side, divide it and use the log formula also, whichever is comfortable for you. So K2 by K1 will come out to be, after calculation, 4.84 roughly. Alright. Now the question is, you have to find out the activation energy, and two temperatures are also mentioned. So whenever you are given two temperatures and you have the rate constants with you, you will simply apply your Arrhenius equation, the modified form of Arrhenius equation. Alright, whenever activation energy, rate constant and two different temperatures are given, the first thing that should strike your mind is, I will apply the Arrhenius equation concept. Which concept? That is log of K2 by K1 equal to EA by 2.303 R 1 by T1 minus 1 by T2. This should strike your mind. Alright? Okay. Now this part we know. K2 by K1. What is it? Log of 4.84. Right? Activation energy is to be found. 2.303 into R. We'll take it as 8.314. Because we are finding out in Joule for the activation energy. No, one second. The question says kilocalorie. Alright. If it is kilocalorie, first let us find it out in calories. So calorie unit would be 1.98. Alright. Roughly equal to 2. You can also put 2 for simplicity's sake. Not an issue. Since calculators are not allowed. Okay. Now 1 by T1 is 1 by 298 minus 1 by 320. The second temperature. Right. So if we solve this out step by step. So log of 4.84 becomes equal to 0.684. Okay, and if you solve this part, EA by 2.303 into 1.98, or if you take it as 2 for your simplicity's sake, this would be 4.6 roughly. Alright, and this is 1 by 298 minus 1 by 320. Alright, that. Okay, so this comes out to be the 1 by 298 minus 1 by 320 comes out to be 2.307 into 10 to the power minus 4. Now, if I have made any calculation mistakes, do let me know in the comment section below. Alright, so multiply this part and then divide this whole thing. So, EA will come out to be around 13638.49 calorie per mole. Alright. But the question is asked in kilocalories, so divide the answer by 1000. We'll get it as 13.6 kilocalorie. If that matches with any question, any option, yes, it is the option number B. Alright. So this is your question number 5. I hope the method is clear of solving. If there is any calculation error from my end, please tell me in the comment section for sure. So the last question for today's video is, see, there are 4 graphs mentioned. So the question says Following graphs show the plot of log T half versus log A, where A is the initial concentration of the reactant. Which of the following represents a zero order reaction? Fine. So, if it is a zero order reaction, children, the T half comes out to be uh, A0 by 2K, where A0 is the initial concentration. Now just replacing with the terms that is given in the question, that is T half is given equal to A0, initial concentration is mentioned as A, right? Now if you ask me, ma'am, where did you get it from? I'll just do it for you, just for your understanding. A0 minus AT equal to KT. This is your zero order form, right? Now T half means the time when 50% of the reaction has proceeded, right? So 50% of the reaction has proceeded. So at time T, how much reactant will be left? 50% reactant will be left, right? So 50% reactant left means it will be 1 by 2 of A0 equal to K into T half, right? So this will be half A0 itself equal to K into T half. So T half becomes the one which I have written, A0 by 2K. Okay, clear so far? Alright. Now, applying log as given in the question on both sides, we'll get, okay, log of A by B would be log A minus log B. Right? Understood. Now, even if we neglect the factor, the constant factor, it will not give any change, alright? So, we are neglecting that for our own simplicity. Log A minus log K, suppose, alright? So, we are plotting what? Log T half versus log A. So, log T half is being plotted versus log A. Just a second. So, what are we doing? We are just doing the plot for log of T half versus log of A. Right? So, see students, this is the Y, this is X. Right? So, what can we say? That this part is the C constant part? Yes or no? Right? Now, if we try to plot this, we are seeing that, okay, even if we keep the constant term will come this side, right? So, one second. The main motive to understand is, if we are putting this minus sign here, students, then the plots that are given to you in the question does not match at all. Have you seen very carefully? If it is a negative intercept, then it should be starting somewhere from here. Yes or no? If it is a negative intercept. Now, that part is not mentioned, or that option is not there in your question. So, what to do? You'll not solve the question, is it so? And that's not going to happen, because we can solve the question. How? Just change it a little bit. How can we change? Log T half is equal to log A. This was log 2K minus log 2K. Now, if I put a plus sign, what should be this? Log of 1 by 2K. Right, students? Just reciprocating it. So, the sign will change. Right? Yes or no? So, if the sign changes to positive, now we have the form of y is equal to mx plus c. Right? In this form. Now you have a positive intercept. Now which is the option? This one. Option number A. Having a positive intercept. The intercept is log of 1 by 2k. Right? Understood, students? So this will be option number A. So you have to, one thing that you have to understand is, now the questions are impossible. You have to just convert your questions according to your, or convert your answers according to your questions requirement. Okay, do not just leave a question. If you have come so far, if you have done this part till here, then there's nothing to leave the question for. After this is just basic mathematics to change the form. Right? So do not give up on a question. Try to continue it as long as you can. Okay, that is my tip for you students for your exams. All right. So we have come to the end of the discussion for chemical kinetics. I hope all the questions have been understood by all of you and there is no doubt. If there is any doubt, please let me know in the comment section below that which question you had a doubt in or any other method to solve a particular problem. If you have any suggestion, let us know. Okay, and keep practicing and keeping yourself motivated all the time until your exams. We'll shall meet in the next video with some other topic maybe. Till then, stay safe and keep practicing.